welcome to another college math video. In this video we're going to look at combinations. The previous video was about permutations where the order mattered, first, second, third through whatever place, but with combinations we'll be placing things that the order doesn't matter. So our objectives for the video: look at vocab and concepts related to combinations, and then evaluate expressions and solve applications using combinations. We're also going to compare to permutations, since that's really the most difficult part of this. Is if you can decide which formula to use, then you're good to go. All right, so the definition for a combination, this is, let's make sure we're good here. Yes, a distinct group or set of objects without regard to their arrangement. And the most important thing is without regard to their arrangement, aka order does not matter. It's hard to understand, how that differentiation would need to take place until we see some examples. But for now, just know that that's what's the important thing. Order does or doesn't matter. With combination, it doesn't matter. And so our combination formula, where we have R objects being selected from N objects, it feels exactly the same. N objects with R of them being selected felt the same as permutation, but the distinction here is that the order doesn't matter. And so the formula, NCR, we saw this is something that you can type in the calculator or you can do by hand in the previous video. It's n factorial divided by n minus r factorial. That's the same as permutation. With one additional component, an additional r factorial is divided out, and that's where we divide out repetition amongst the top whatever items that we care about. You don't need to have the details of the formula memorized. You don't even need to have the formula memorized because you can do it in the calculator, but I want you to understand where it's coming from. So let's see an example. So we have the same example, 6 women on the Belarus women's Olympic team, and we're going to do it 2 ways. How many ways are there to get a top 3 versus first, second, third? First, second, third is what we cared about in permutation. Order mattered there. So let's just note that again. The permutation, order mattered. First, second, third. So we could use permutation, 6. 3 of them are being picked, and we care about the order, which gave us 120. But it's a different thing to care about to say how many different ways there are there to get a top 3. There'll be fewer ways because here, with permutation, we've got a lot of variation amongst who is first and second and third. But if we only care about a top 3, then all the times that first and second were different and first and third were different, we can divide those out. That's where the additional component comes from. Top 3, which is a combination, because the order of those top 3 doesn't matter. Looks like this. There are still 6 total, and we're still selecting 3 of them, but the order of those top 3 does not matter. So I'm going to do this one by hand so you can see it, but know that you could just type it in the calculator. It's 6 factorial divided by 6 minus 3 factorial times whatever r is, which is 3 factorial. And the only additional component here from the permutation is this piece right here. This number divides out repetition amongst the top 3. Where the 6 minus 3 piece is dividing out repetition amongst the bottom 3, amongst 4th, 5th, and 6th place. Because in permutation, we only care about 1, 2, 3, so 4, 5, 6 don't matter. We can divide out all that variation. All right, so if we do this by hand, just so you can see it done. And then this one is 3 factorial, so there's a 3 factorial and a 3 factorial. We can divide out or cancel out a 3, 2, 1. The 1 doesn't do anything, and the 3 and the 2 can divide out the 6, which leaves us This is just me doing it by hand. You do not have to do it this way. 5 times 4, 20. So there are 20 ways to get a top 3 from 6 gymnasts on an Olympic team. And there are 120 ways to get a first, second, third from 6 gymnasts on an Olympic team. It's not always as simple. You're wondering, could I just subtract 100? It doesn't work like that. It just varies problem to problem. The most important thing to note is if the order matters amongst your top whatever, or if it doesn't. If it matters, permutation. If it doesn't matter, combination. Okay, so another example. There are 10 colors of powder you're considering buying for Holi, which is a Hindu spring festival in India and Nepal, also known as the Festival of Colors or the Festival of Sharing Love. 10 choices of color. You have enough money for 6. How many combinations of 6 colors can you buy? All right, so the order of those 6 definitely doesn't matter. The order that you bring them to the counter, the order that you throw them in the air, sort of like a color run, that doesn't matter. It might be fun for you to do different variations on them, but you're just choosing 6 of them from the 10. So the order does not matter, which means it's a combination. You have 10 different choices, and you are selecting 6 of them. So 10, choose 6. You can do it by hand, you can do it in the calculator. I'll do it one more time by hand. Remember, if you're looking for the steps on how to type this in the calculator, the previous video has those steps. This is 4, so we have 4, 3, 2, 1, and a 6, 5, 4, 3, 2, 1. I like to, instead of doing all this multiplication, cancel whatever I can out. You don't have to do that. You could just multiply it all. The 2 and the 4, cancel the 8 out. And then the 3 and the 9 leaves a 3. So I have 10, 3, 7. And that's it. 10 times 3 times 7 gives me 210. Or you can put it in the calculator and you'll get the same thing, 210. Either way. Okay, so again, the most important thing to note is if the order matters. If it doesn't, it's a combination. If it does, it's a permutation. One more example. There are 8 countries in the northern part of Africa. We have Western Sahara, Morocco, Algeria, Tunisia, Libya, Egypt, Sudan, and South Sudan. This is one way northern Africa has been defined. In different places, they define it different ways. We're just going to go with this definition for this question. Let's say you want to visit 5 of them total. How many different ways can this be done? So we don't necessarily care about the order that we visit them. We just know that we want to go to 5 out of the 8. How many different ways could we choose 5 from the 8? Order does not matter. So it's a combination. We have 8 choices and we are selecting 5 of them. So type it in the calculator. 8. Select 5. Looks like we get 56. 56 different ways you could choose 5 countries to visit from the 8. Okay. All right, so we have some practice problems. This is just one quick problem, and then hold off on the other problems for now. So go ahead, run through this one, pause the video. We'll see if we're on the same page. Okay, so for this problem, a gelato store in Italy sells 10 flavors: limon, which is lemon; baccio, which is hazelnut; menta, which is mint; riso, rice pudding; tiramisu, flavored like the dessert; crema, which is custard; cioccolato, chocolate; pesca, peach; fragola, strawberry; and vaniglia, vanilla. Determine the number of 4 scoop sundaes you can order. So there are 10 choices. You are picking 4 of them. While it might be important to you the order that they're listed or that they're sitting in your sundae, you're just getting the 4 scoops of ice cream. So the order does not matter. Which means combination. So you have 10 choices and you are picking 4. 10, choose 4, you can do in the calculator, and we get 210. So 210 different ways you could choose 4 different scoops of ice cream of gelato for your sundae. Couple fun gelato facts. Lower fat content than ice cream. It's made with whole milk. You can read through the rest. All right, one more set of practice problems. So in this last little set, all I want you to do is determine if it's a permutation or combination. You don't actually have to evaluate, because once you know which formula to use, the computation part can all be done in the calculator. So go ahead, pause the video, and just answer permutation or combination for each of these 4. Okay, so let's see if we got the same answers. You buy a tourist pass for Berlin with 30 options and you get to select 3 of them. How many different ways can this be done? Does the order that you select those 3 matter? Might vary what your day looks like, but you just have to pick 3 of them, so the order does not matter, which means it's a combination. Celine is visiting France and wants to taste some French cheeses. The store she stops at is sampling Mimolitaire, Brie, Camembert, Roquefort, and Bleu de Bresse. She only wants to taste 2. How many different ways can this be done? The question, does order matter? The order in which she eats the 2 cheeses definitely doesn't matter. So the answer is combination. I suppose a French person might argue with you that the order that you taste them does matter because they'll taste different. But the truth is she just has to pick 2, and it doesn't matter how she picks those 2. Okay, number 3. The players on the Brazilian soccer team elect a captain, sub-captain, and equipment manager. If there are 15 players on the team, how many ways can the election happen? Does the order matter? This is a little tricky because it doesn't necessarily say first, second, third, but it's a different meaning to get captain, to get sub-captain, and to get equipment manager. So while it's not necessarily first, second, third, you could think of them as captain first, sub-captain second, equipment manager third. There's a difference in which position you get, so the order does matter. It's a permutation. Okay, and the last one, there are 8 top Dominican players. How many different ways are there for the players to finish a tournament in first, second, third, fourth? Very clear cut. Order does matter here. So this is a permutation. All right, so this video in particular focused on combinations, looking at the problems where the order does not matter, but it was also important to lump in sometimes where we see it does matter so we can come up with a differentiation. All right, this is the end of your probability section, so I'll see you soon for another video.